Hey folks, this is the sixth video in my series that focuses on automating the creation of a Google Slides presentation deck using Google Apps Script. To this point in the series, we have learned how to automate the creation of a deck, how to move that deck to a destination folder, setting up some development logic so that we can delete newly created decks so that we don't have to, learned how to append a slide into the created deck, and how to add text boxes. The result of this script to this point is a presentation deck that has a single slide that has two text boxes within it. The last text box says that data is sourced via Pro Football Reference. And if you've been following along since the beginning, we currently have an empty Google spreadsheet. So this video is an optional portion of this series where I will be showing you how to write some Python code in order to scrape data from Pro Football Reference, clean it, and then send it to your spreadsheet. In the event that you are not interested in this and only want to focus on building out the deck, you can skip this video and go on to video number 7. As long as you have the ability to get data into your deck, you're fine. But for the purposes of completeness, I thought it would be helpful to demonstrate this. The outline for today's video will be a brief demonstration of this Python code, and then I will be doing a full tutorial showing you how to write it yourself. We'll be leveraging the pandas library, the NumPy library, the request library, Beautiful Soup 4, and Google Spreadsheets library called gspread. We'll be building out a few custom functions that will allow us to first scrape Pro Football Reference and then send data to Google Sheets. So you'll see in my demonstration deck, we have an empty sheet. I am going to go to my Python script. I'm going to go to runtime, and I am going to select run all. You can see these check marks are indicating that there is no error. So we are referencing some names, and then we are creating a custom set of data for those teams, and we are then sending that data to Sheets using a custom function called sender. When we go back to our sheet, you can see that instead of being blank, we now have the data that we have scraped from profootballreference.com. So what you will need for this demonstration is Google's Collaboratory Notebook, which you can access for free using Drive, and a URL to profootballreference.com, which I will leave linked in the description. So we will begin by navigating to our Google Drive folder where we have our project. You can see I am currently in my decks folder. This is where my automated decks will appear. So I'm going to go back to the parent folder where you can see I have a spreadsheet called automated deck. This automated deck sheet is blank. This is where I will be sending my data from Pro Football Reference. I'm going to go back to Drive. I'm going to select New. I'm going to go to the More submenu, and then you can see that I've already downloaded Google Collaboratory onto my Drive, so it's available to me. If you do not see Collaboratory, you can go to the Connect More Apps section, click on it, go to the search bar, and start typing in Colab, C-O-L-A-B. It will pop up, and then you can authorize it for your Drive. Once you're ready to go, we will go to the Google Collaboratory option, and we will open up a new notebook. We're going to go up into the menu bar, and we are going to rename our notebook Data Extractor. We're going to hit Enter. We will begin by importing our libraries. So we will import pandas as PD, which is short for panel data. That's what pandas stands for. And typically, you will see pandas cast, that's what that as is doing, as PD. We're going to hit enter, and we are going to import NumPy as NP, which stands for numerical Python. That is also typically cast as NP. That way you don't have to write NumPy every time. You don't have to write pandas every time. We're going to hit enter, and then we're going to import requests. We're going to hit enter, and then from BS4, we will import beautiful capital S soup. We are going to engage our runtime. So you can see we're connecting up here. That's how you connect to Google's compute engine, which will give you RAM and disk space in order to run Python code. We're going to hit the play button here, which will then show us that we have no errors importing any of our libraries. You may be asked to authorize runtime. I have already authorized runtime on a couple other collaboratory notebooks, so I wasn't prompted to do so, but I might be at a future date. If you are currently getting some menus that are just saying allow runtime, allow it. It's merely just allowing you access to Google's compute engine and such. Cool. So what we'll do now is we're going to open up a new tab in our browser. And we're going to search for Pro Football Reference. We're going to hit enter. And we're going to open up profootballreference.com. So what's going to be important for us to understand is our URLs. So you can see that we have pro-football.reference.com. Our slide deck, at least in this tutorial, is going to be focusing on the NFC East. So I'm going to open up a new tab for the Eagles, as well as a new tab for the Cowboys, as well as a new tab for the Giants, and a new tab for the Washington Commanders. When we go to the Eagles page, you can see that the URL is now has some slashes in it. So you can see that we are now in teams, and then we have PHI/2023. Now, we don't just want 2023 data, we want the last 5 seasons of data. That's what we're building our slides out to look at. So what we're going to try doing here is removing that 2023 portion of the URL, so that's just team/PHI, and then we'll see where that takes us. So now we are on just the Eagles franchise encyclopedia page. And you can see that we have a retired number section. And then we have these team record leaders and league ranks. So that looks pretty good. In my script, I'm referencing index.html. So I'm just going to use that to make sure that this is the same thing. And it is, so that's great. So we can either use pro-football-reference.com/teams/whatever the abbreviated version of the team name is, and that will work the same way. So we're going to go into the Cowboys menu, and we are going to see what their URL path is. So you can see that's DAL, which is short for Dallas. We're going to go into the Giants tab now. And you're going to see we have NYG. And then we're going to go into the Washington URL, which should be WAS. Sorry, everything's a little bit slow because Pro Football is a little bit heavy. Yep, so we got WAS. Wonderful. So we're going to go back to our data extractor, and we're going to add in a new code block. And we are going to create a variable called teams, and we're going to set that equal to an array. And what we're going to pass into this array is going to be those abbreviations that we saw for each URL. So we're going to add in a single quote, and we're going to enter in PHI for the Eagles, single quote DAL for Dallas. We're going to add a comma and hit space. We're going to add single quote, and we're going to add in NYG for the Giants. We're going to go to the right. We're going to add a comma. We're going to hit space. We're going to add a single quote, and then we're going to enter in WAS for Washington. We're going to run this cell so that we have it available to our script. And now we have a variable that is set to a list or an array with the team abbreviations. And this will allow us to loop through those abbreviations so that we can pass it into a function that will allow us to extract data for each team. So we're going to add in a code block now that is going to be a custom function. So we're going to add in a hash to add a little comment here. And we'll say custom function for scraping team data. So we're going to hit enter, and then we're going to use def, which is how we create a function. And we're going to call this function get_stats. We're going to have an empty parentheses, and then we are going to pass a single argument, which will be team. We're going to go to the right of our parentheses, and we're going to add a colon. We're going to hit enter. We're going to add in a comment that denotes that we are looking for the URL of the team page. So we're going to hit enter. We're going to create a variable called URL, and we're going to set that equal to f-string, single quote, and we are going to enter in, if we go up into this Eagles version of Pro Football Reference, and we're going to copy that beginning portion of the string. So we're going to Command C, and we're going to go back to our data extractor, and we're going to paste it into our single quote. We're going to add curly brackets, and then we're going to pass in that team variable. Now, for my purposes, just to make sure it's in line with the script that I have, I'm also going to add backslash here and index.html. It doesn't seem like you need to have this. I think you can just run pro-football-reference.com/teams/ and then whatever the team abbreviation is. So if you want to do a division that is not the NFC East, all you have to do is make sure that you have the correct abbreviation for the team that you want to extract data for. I haven't tried this with other leagues, but I would presume that this is how it works for other sports. So if you want to use the NHL, the NBA, or the MLB, this is probably how you would do so. We're going to hit enter twice. We're going to add in a hash for another comment, and we are going to send a GET request to the URL. So I'm going to just clean up that typo there. I'm going to hit enter, and then I'm going to type response, and I am going to set that equal to requests.get parentheses URL. So what you can see is Google's Gemini appears to be autocorrecting because they've seen me write this in before, which is totally fine. This video is about explaining how this works. We're going to hit enter twice. We're going to add in a hash, and we are going to parse the HTML content. We're going to hit enter. We're going to declare a variable called soup, and we're going to set it to beautiful soup, parentheses, and then we're going to use response.text, comma, single quote, HTML.parser. We're going to go to the right, we're going to hit enter twice, and we're going to add in a comment, and then we are going to find the specific table with the class known as sortable stats underscore table. Okay, so I'm going to write this code out, and then I'm going to explain why and how we're doing this. So we are going to declare a variable called table, just like Gemini is saying. We're going to type soup.find, parentheses, single quote, table. Go to the right of the closing single quote, add a comma, hit space, add in curly brackets, enter in a single quote, class. Go to the right of the single quote, add a colon, space, single quote, sortable, space, stats underscore table. We're going to go to the right. We're going to hit enter. we're going to add in a comment called extract rows. So before we do that, I'm going to go back to Pro Football Reference. So when you're scraping a website, what's happening is you're engaging with the HTML, which is the structure that creates the page layout. So when you see this image over here and this text, which is like very large and bold, and then this text here that is smaller and bold, and then this text over here, which is just plain text, this is all HTML, right? It's being stylized for you in a specific way so that it appears the way that you're seeing it, but the underlying bones of the website are HTML. So in order to evaluate our HTML, what we can do is inspect the web page, and then we'll get this panel that opens up in the left-hand corner over here. And then this will allow us to start seeing all, so like you can see here where like I'm hovering over it and I'm starting to get the values that are in between these P tags. So you can see that all-time rushing leader is in between a strong tag, which is why you're getting that bolded text. Additionally, you can see that we have an ahref here, which is how you create a linked set of text. So you can see that the word here is LaShawn McCoy. That is in between an ahref tag, which enables the HTML to link up another web address to then have LaShawn McCoy be a clickable link when the user goes to the web page. So what we're going to do is we're going to scroll down, and what we want to scrape is this data table here. So you can see this data table is going to present a few challenges for us. Number one is that it has a lot of data. And number two, the first row is a span row, which means that these values span several columns. So you can see that we have 1, 2, 3, 4, 5, 6, 7, 8 columns here that have one merged cell, right? So if we were in a spreadsheet, this would all be one cell. This is a span column in an HTML table. So we want to skip over this, which is what we'll figure out how to do. But first, what we need to do is find where this table exists. So what I just did was I went to the table and I right-clicked and hit inspect. And then you can see in here that we got brought down to the table in this portion of the HTML. So you can see that we have this header here, right? So it has this like captions tag here, right? Team records, leaders, and league ranks table. So you can see up top, we have team records, leaders, and league ranks. So when we open up the table head, we have a couple different things going on. We have our table class here. That's what we want to find, right? So we are in this class table container, and then you can see this table class is sortable space stats underscore table. So when we go back into our Python script here, you can see that we are using the URL in order to get a response. So when we did request.getURL, we are accessing the HTML of the web page, or rather we're accessing the web page. And then we're using that response variable here within Beautiful Soup. So we're using response.text, and then we're using the HTML parser. So we're getting the HTML via Beautiful Soup, and we're saving it to the soup variable. Within our table variable, we're using soup.find to find a table class. And if you scroll through the entirety of this HTML, you'll find several tables, right? And when we say find the class of table, and then we're using a set of curly brackets, we're able to identify that we want the stats underscore, the sortable stats underscore table, which enables us to identify that this is the one that we're looking for. This might take a little bit of finessing, and it requires practice and some experience to kind of jam around. So if this is the first time that you're working with web scraping, you might want to look for a beginner tutorial that does a better job than I have of outlining the fundamentals. My aspiration is kind of to just give you a breadcrumb of how to do this, and hopefully this is an exposure point for you to investigate this further if you're interested in this type of work. Now that we have the HTML that we're looking for, we are going to look to extract the rows. Now, I am going to print out that table variable to try to give you a better sense of what we're going to need to do. So I'm going to run the cell. Oh, I forgot. My apologies. Because this is a function, we can't look at it thus far. So you don't have to do this. You can if you want to. I'm going to comment out the function, and I am going to hit Shift Tab. And instead of having this line in here, I am going to just hard code PHI in there. And then I'm going to run this cell, and I will get the results of my web scraping. So you can see as I scroll down here, we are getting all of the data from that table, right? So you can see we're getting table class equals sortable stats underscore table ID equals team index. Then we're getting that caption of team records, leaders, and league ranks table. And then you can see that we're getting like table headers in here that identifies that first row, right? So you can see that we have those span columns in here where it says call span equals 3, call span equals 8. So that's that first row in here, right? So you can see 1, 2, 3, 4, 5, 6, 7, 8. That's what's being represented by that call span right here, right? It's indicating that it is spanning 8 columns. This is spanning 3 columns, 4, 2, 2, 4, 5, right? We don't want any of that. So that stuff is inside of the table head. You can see we have that table head tag here. And then we have this TR class of over header. We then also have this next row, right? So that's what's indicated here. When you have a backslash in your HTML tags, that means it's the closing tag. We then have a new table row, which is then year, league, team, wins, losses, ties, all that type of stuff, right? So when we go back in here, you can see we have year, league, team, wins. That's where we actually want to start scraping our data, right? So we're going to have some logical values in here that allow us to start looping through the table in order to extract the values that we want. So what I'm going to do is close down this output because I think it's pretty clear but I'll do it just to kind of show you. Once we get down a little bit further, you can see that we start to get those values that we want in here. We have to scroll down a little bit. Sorry, it's not abundantly clear, but basically we have like the HTML in here that we're trying to get out, and it's very messy. So we're going to start looping through that table variable to extract the data rows. So we are going to begin by establishing an empty array. So we'll have rows is equal to, and then just 2 square brackets, and we are going to loop through our table variable in order to find the values that we want. So we're going to do for row in table dot find underscore all, and we're going to do a single tag or a single quote, sorry, and we're going to pass that tr tag. We're going to add a colon. We're going to hit enter, and then we're going to say we're going to create a variable called cells, and we're going to set it equal to row dot find underscore all, and we are going to look for, we're going to pass in a list of things that we're looking for. So we're just going to be looking for table headers and a single quote of table data. We're going to go to the right. We're going to hit enter, and we're going to look for cell underscore values, And we're going to set that equal to an array of cell dot text dot strip parentheses. We're going to do space, and we're going to say for cell in cells. We're going to go to the right, and we're going to say rows dot append, and then we're going to pass in those cell values. We're going to hit enter. We're going to leave our for loop, and then we're going to print that rows variable. I'm going to hit run on my cell. And now you can see what we're getting is that first row where we have a null value, and then we have points and a null value, top players, offensive rank, so on and so forth. We're then getting a row called year, league, team wins, all that type of data in here, right? And then we're starting to get 2023 NFL, Philadelphia Eagles, 11-6-0. So basically what we've done in here is we are finding all of our table rows, and then we're identifying any that are tagged as a table header or a table data. And we're looping through all of them. We're removing any excess white space, and we are doing I apologize because I forget what the technical name is for it. I apologize. But we're doing a comprehension loop, I believe, where we're saying for cell in cell. So we're basically doing like a loop within a loop here. So it would be the same thing if we created another for loop, but we're like just cleaning up the text in the cells using strip. And then we are taking those values and we are appending them to cell values. And the reason that we're doing that is because we want to pass those things as an array. So we want these values to be in single brackets so they can be pushed into the empty array, which is the rows variable. And now that we have the data that we want, that we've scraped from Pro Football Reference, we are going to create a data frame so that we can clean that data, so that we can just have the data that we want. So I'm going to go back to, I'm not going to go back to, but in my example, I just pulled in the year and the team name and the wins, losses, ties, and then just the coaches, top passer, and the top receiver. Because we're basically right now what's happening is we're pulling in all of this data, and you may want it for your slide. Feel totally free to scrape whatever you want to, but I just want the last 5 years of data for certain columns. So within my function, or what will become my function, I am going to clean that data up a little bit. So I'm going to remove that print statement. I'm going to add in a comma, and I am going to say create a pandas data frame. And we're going to do so by declaring df, and we're going to set that equal to pd.dataframe. And then we are going to, you know what, for now, let's just pass in that rows variable so you can see what I'm going to do to clean it up a little bit. So we're going to do print df. I'm going to run that again. And now you can see instead of getting a list of lists, that's what we had, we now have a data frame that has columns and rows. But there's a couple problems with when we just pass that raw data into a data frame. You can see that our column headers are 0 indexed, and we have those span columns in here. So you can see we have points, and you can see that it's actually lined up weird because of the span columns not being appropriately formatted when we scrape the data. So what we're going to want to do is leverage some deeper specificity within the data frame method. So instead of just passing rows into my data frame, I'm going to do some cleanup on it. So before I do that, I'm going to show you what we're going to do. So I'm going to print that rows variable once again. And now you can see our data is structured in a list of lists. You can tell that because we have this square bracket here that is housed within this square bracket here. So because we have 2 brackets, that means we have a list, which is the first bracket that we have highlighted there. And then we have lists, more than one list within this list of lists. And the reason that you can tell that is because we also have a square bracket over here. So this square bracket is related to this square bracket here, which is denoting list 1. And within a list, they are 0 indexed. So technically, we would call this the first list, but if we wanted to reference this list, then we would call it 0, because 0 index means that the first value is 0. So I'm going to do that real quickly just so you can see it. I'm going to print row 0. Now you can see we're getting the first list. Now we want to exclude the first list. We don't want that to be in there. So what we're going to do is leverage some functionality within the way that you call lists by denoting where we want to start. So if we wanted to just exclude the first list in here, we could enter in a 1 and then enter in a colon. And when we run this, you'll see that now, instead of starting with that list that we didn't want, we're getting year, league, team, wins, losses, ties. That's perfect. That's exactly what we want to see. So within pandas, we have the ability to, I'm going to uncomment this up top here, and I'm going to, you don't have to do this, but I'm going to comment out that rows 1 colon that we just did. In addition to just saying that just passing rows in here, we can also declare that we want the data to be equal to rows, which means that we can also, and here's a better way of seeing it, we have the ability of determining the columns that we want as well as the data types that we want. So what we're going to do is we're going to declare our columns as being equal to rows, single quote, 1, because that's what we want, right? So we're just going to call that rows 1. Now you'll notice in here, we have rows 1 colon, which includes our header rows as the first row. Now we don't want our header rows to be part of the data, right? So the same way that we're excluding the first list, aka list 0, we are going to exclude the second list, aka list 1, because we are representing it in our columns, right? So we've defined columns are equal to rows, and then we're calling for list number 2 in the 0 indexed list of lists. So next to that data is equal to rows, we're going to add in a square bracket, and instead of starting at 1, we're going to start at 2, and we're going to pass in a colon. Now, when we run this data frame, check it out. We have successfully eliminated the row that had span columns, and we have successfully implemented the correct header row with the correct data. So now you can see the wins are lining up with wins, the team is lining up with teams, the league is lining up with league, and the year is lining up with year. This is exactly what we want to see. So the next step that we are going to do is we will clean our data frame. So I'm going to remove this print statement in here because we no longer need it. And I am going to redefine data frame. So I'm going to declare df is equal to df, and then I'm going to use a list of lists in order to pass in the columns that I want. So I want to have the year, so I'm going to add a single quote and pass in year. I'm going to go to the right, I'm going to add a comma. I want the team name, so I'm going to add in single quote, and then I'm going to pass in capital T, M. I'm going to go to the right, I'm going to add single comma, and then a single quote for W. I'm going to go to the right, comma, single quote for L, go to the right, comma, single quote for T, go to the right, comma. I want the coaches, so I'm going to pass that in. So we have to scroll a little bit, but then you can see, oh, I apologize, you can't see it because there's these ellipses here. So just take my word for it. Or if you want to see all the data that's available to you, you can just go back to the website over here, close out that inspect, and then decide what you want. But we're going to want the passer and the receiver as well. So we're going to go back and we're going to add comma, space, single quote, passer, go to the right, comma, space, receiver. And now we're going to go to the right of our variable, hit enter, and we're going to print df again. We're going to run it. And now you can see we have a nice clean set of data. However, that's not completely true because we have an issue here where we have this asterisk here in team names. So what we're going to have to do is use a replace method in order to remove the asterisks. So we are going to access the team column. So we'll do df with square bracket, single quote, capital TM, and we're going to set that equal to df bracket, single quote, capital TM, dot str, which stands for string, dot replace. We're going to use an open parentheses with a single quote, and then we're going to pass in the special character of asterisks. So this will allow us to find the asterisks within that column, and we're going to replace it. So we're going to add a comma, we're going to add a space, and we're going to just add in single quotes. Make sure that you do not have a space between the two single quotes, because that will add in an extra character that will be seen by the computer program, even if it's not noticeable to your eye. So if you replace the asterisk with effectively a null value, which is two single quotes or two single quotes together, then you will have the name in the same way that it appears in all the other instances of the name. So we will print that out to make sure that it works. And now you can see that the team name is appearing exactly the same across all the other instances. Now, as I mentioned, we only want the first 5 years of data. So what we're going to do is hit enter after cleaning up the team name, and we are going to define df as being equal to df.head with open parentheses, and we're going to pass a 5 in there. Head allows us to see the first 5 results of the data frame. Now, I just want to point out that if you look at lines 95 and 96 of the data frame, we have values that have not been cleaned out, which is the result of the way that the table is structured on the website. Now, this tutorial is not going to go into how to clean up that full collection of the data because we have only designed this for the first 5 values. In the event that you are experiencing this issue, please reach out in the comments or send me an email and I'll do my best to help you with it. But I won't be addressing it in here because we're not going to be using anything after the 2019 season. So when I hit run, you can now see that we have a nice tight set of data for the last 5 years where we have the values that we want. Now we have an aspect that we want to, or a problem that we need to solve for one of the teams in the sample, and that's with Washington. So I'm going to change PHI to WAS, and I'm going to rerun my code block. And you can see that Washington went through a name change in 2 separate occasions, where they are now the Commanders, but they were previously known as other things. For our purposes, we want them to have the same name. Now, I didn't change the team name. I don't want to have a discussion about the team name. All I'm going to say to you is that for this purpose, we want to have a single name so that when we're building out a slide, we have the ability to reference the Washington team. So in addition to cleaning out our data frame, we are going to hit enter and add in a comment that will standardize the Washington team name. So we're going to hit enter and we are going to use a conditional. So we're going to say if team is equal to single quote WAS single quote, we're going to have a colon, we're going to hit enter, and we're going to say df square bracket single quote capital TM single quote square bracket space is equal to, and then we are going to write Washington space Commanders. This way, anytime that we see WAS in the data set, we will get the name that we want. So we're going to go down here and we're going to hit print, and we are going to print our data frame. So what we should see when we run this is that instead of having these 3 variations in here, we will have a single team name. Oh, my apologies. Something went wrong. Oh, I see. So that's because I wrote in some code that came from my function. So I'm going to say if df square bracket capital TM is equal to Washington, then that is the logic that we want. Huh, what's going on? Okay, you know what? I'm going to save that until we have our argument that gets passed in here. Because, you know what? I'll do it like this, actually. This will help us set up our function. So placeholder for input. I'm going to hit enter, and I'm going to declare team is equal to, and then I'm going to hard code the team in here like this. I'm going to go into the string, and I'm going to remove the hard coding, and I'm going to pass a curly bracket, and we're going to have team in there. I'm going to clean this up a little bit, and then I'm going to say if df team is equal to Washington, and I'm going to change that to team. And now when we run this, this should work. Wonderful. So you can see now we have a standardized name that allows us to dynamically clean it up if it is Washington. I'm going to go in here and I'm going to change it back to Philadelphia, and I'm going to run it, and you can see we didn't get an error, and now we get the Philadelphia team. So this conditional will help you clean it up. I forget if there are other instances where we have team names changed. I would assume it's with Oakland to Las Vegas and potentially the Rams going from St. Louis to Los Angeles. But there are probably other instances, if you use other divisions, where you would have to standardize the team names in the event that you want to, when you get them into your spreadsheet, if you want to access them robustly. So what we're going to do now is create a return statement for our data frame, and we are going to highlight all of our code. So I'm going to clear this output here. I'm going to highlight all of this, and I am going to hit tab once. And then I'm going to uncomment this function up top here, and I'm going to remove this placeholder for input because we no longer need it. So you can see we now have this function in here, which we are going to test out. Excuse me. So we're going to create a new code block here. And what we'll do is just call it test. And we're going to set it equal to get stats. And then we're going to use parentheses, and let's pass in PHI. And then we are going to print test. And we're going to run it. And oh, interesting. Why did that come back like that? My apologies. Looks like we have another issue going on. So we are using get stats to pass we'll get one argument to pass in there. And then we're using our URL to get a response, which then gives us that soup, which then should result in a data frame. And then we should return this data frame in here. I wonder why that happened. Oh, you know what? It's because I didn't run that cell again. My apologies. So I ran that cell, and now I'm running this cell, and perfect. Now we got it. So my apologies. The reason that we were getting all that is because I didn't run this function after converting it from a block of code into a function. So now we have the ability to pass in any team name that we want, and then we get their results. So what we're going to do is we are going to loop through it, and we are going to collect all of our values. So we're going to create an empty array to append data. So we'll call it football underscore data, and we're going to set it equal to a square bracket. We're going to go to the right. We're going to hit enter. We are going to loop through the team names, and we are going to say for I in teams. And let me just make sure that's the variable that we have. Yep, so this is teams. So for I in teams, we are going to create a collector array. Will be called collector underscore array and set it equal to a square bracket. And oh, you know what? We'll just call it collector. We'll hit enter twice, and then we will get the data using the get data function. And we will do data is equal to get underscore stats, and then we will have an open parentheses, and we will pass I. So what's happening in our for loop is we are looping through all of the names in the teams array, and we are passing them to the get stats function. Once we have those stats, we are going to append the data to the empty array. We're going to hit enter. We're going to do football underscore data dot append, and then we are going to pass that data that we extracted using the getStats function. And we are also going to just extract the values. So we're going to do data.values.toList with an open parentheses. We're not going to pass any values. What this will do is this will just extract the data values and not the headers that come from there. So like, for example, when we append to football data, we will not be appending year, team, wins, losses, ties every single time. We're just going to be collecting these rows of data and appending them to this football data empty array. We're going to hit enter. We're going to add another comment, and we are going to extract the headers. So we'll say header extract, and we will call it head is equal to data.columns.toList. We'll have an open parentheses, and we'll hit enter. And we will, we're done with our function, I believe. Yep, we will do some list comprehension. We're going to hit enter, and we are going to say values is equal to square bracket item for I in football underscore data for item in I. So what this will do is this will access each array. Because what's happening when we do data.values.toList is, and you know what, I'll print this out so that you can see it. My apologies for not doing so. We're going to print out football underscore data. And what you'll see is we're getting multiple list of lists going on in here. So you can tell that's happening because we have 3 brackets. So you can see that that first list of values is a list, and then we have another list in here. And then if we go past the equals values, you can see that that is remaining a contained list. That's because when we extracted the values to a list and pushed it into football data, it goes in as a list of lists. So then we have a list of lists going on, which is why we're using this list comprehension that is allowing us to loop through each item in the football data array so that we can extract those values instead of having to do this for I in football data and then sending it to another data. This is a compact way of doing what's called list comprehension. So I'm going to remove that print statement, and I'm going to print the values for you. And now you can see we have a list of lists. And the way that you know it's a list of lists is because we have 2 square brackets and we no longer have 3 square brackets. So now that we have that, we can create a payload data frame. So we're going to create a variable called payload, and we're going to set that equal to pd.data, capital F, frame, and we're going to pass in our data as being equal to that values list of lists. We're going to use a comma, and we're going to use columns in order to set it equal to head. And the result will be printing a payload that is a data frame that has all of the data that we've extracted from Pro Football Reference as one data frame. So now we have the data that we want to ship to our spreadsheet. So now what we're going to do is move into the final portion of the video. And apologies, I know I had this collector array in here that wasn't necessary. I apologize, that's just from my development when I was trying to figure out this list comprehension protocol, the most efficient way of doing it. We didn't end up using it in this. It's not a problem, but I apologize if it was confusing why I did that. So the last thing that we're going to use is gspread. So we will be using a code snippet. So we're going to go over here and we're just going to say Google Sheets. And we are going to use saving data to Google Sheets. And we can insert this code block in here. So we do not need basically all of this stuff. Right? So we're going to highlight it all the way up to the sh variable. And we're going to change GC. I mean, you don't have to. I'm going to change it to access is equal to gspread.authorize credentials. And I am also going to import time. So I'm going to hit run, and it's going to ask me to authorize my credentials. So I'm going to select my email. I'm going to select continue. I'm going to scroll down and do continue. Cool. So that worked perfectly. I'm going to hit X on code snippets because I no longer need it. And then I am going to add a new code block where I am going to build out two functions that I use in all of my scripts. And actually, before we do that, we're going to pull in some more gspread exceptions. No, you know what? Let's not do that. I don't think we need it. So what we will do is we're going to create custom functions for sending data to sheets. So we're going to create a function. So we'll do def, and we're going to call this sender. And we're going to use parentheses, and we are going to pass 3 arguments to sender. The first will be the workbook ID, comma, the second will be the sheet underscore ID, comma, and the final will be the data that we want to send. We're going to go to the right of our parentheses, and we're going to add a colon. We're going to hit enter. We're going to say sends data to Google Sheets. And we'll do 3 more double quotes. And we are going to define a variable called workbook, and we're going to set that equal to access. That access is that same variable up here that is authorizing our credentials through gspread. So we're going to do access.open by underscore key, and that's where we're going to pass our first argument, which is the workbook ID. We're going to hit enter, and we're going to create a variable called sheet, and we're going to set that equal to work WB, that WB variable that we just created, dot get underscore worksheet underscore by underscore ID, and we're going to have an empty parentheses, and we're going to pass sheet underscore ID. We're going to go to the right. We're going to hit enter. We're going to call that sheet variable that we just created, and we are going to clear the spreadsheet. We're going to hit enter. We're going to do sheet.update, and we're going to pass in our data. That's the third argument that we are going to pass to the sender function. We're going to add a comma, and then we're going to use value underscore input underscore option, and we're going to set it to single quote, all caps, user underscore entered. What this will do is set our data as if a human being wrote it. If you do not include value input option, then you are going to get special characters that will adjust dates and numbers. So this is the best way, in my opinion, to send data to Google Sheets so that you have a clean data set for you to work with. The reason that we are doing sheet.clear, additionally, this part here, is because when you are sending data to a Google Sheet, you want to make sure that you are writing the exact amount of rows that you need. So if you have a set of data that has 10 values and then you are attempting to update a sheet with only 5 rows of values, you are not going to overwrite the 5 values that still exist in the difference from 10 rows to 5. So I think it's best practice to clear the whole sheet out before you deliver data to it. Cool. So now we're going to create another function. So we're going to declare def, and we are going to call this payloader. And this is going to have a single argument of a data frame. We're going to declare, or we're going to enter a colon, and we're going to hit enter. So the reason that we're doing this is because Google Sheets API has to receive data in a particular way. So we have to send it as a list or a list of lists. So this payloader function is going to convert a data frame into a list of lists. So the first argument that we are going to have is going to be a variable called headers, where we will call the data frame that we are passing to the function dot columns dot to list with an open parentheses. We're going to hit enter, and then we are going to create another variable called values. I'm going to set that to df dot values dot to list with an open parentheses. This is the same thing that we did when we were extracting our values from Pro Football Reference, where we were denoting the values that we wanted and the headers that we wanted. Same thing is happening here with payloader. We're going to hit enter, and then we are going to return space, square bracket, headers, and then we're going to go to the right of that square bracket, hit space, add a plus, and then we are going to add our values. So what's happening here is we are saving our headers to their own array, which will then be added to, using comprehension, the values array of arrays. That way, the headers are then one list in a list of lists. So if you don't put the headers inside of square brackets, then they will be added to a list of lists, which will mess up the format. So you will no longer have a two-dimensional array or a list of lists. You will have something else. So by adding, the headers to square brackets, you are creating a list, which is then just added into the list of lists. So now that we have these functions, we can hit the play button. You can see we have no error. And now we can move into the final portion of our code. We're going to call the sender function, and we will use parentheses. We'll go to our blank spreadsheet, and we'll go up into the URL. You will highlight the values after the d/. You will copy them, and you will add in a single quote, and then you'll pass them as the first argument. You'll go to the right of the single quote, you add a comma, and then you'll look for your sheet ID. We're going to go back to my sheet. So anytime that you open a new Google Sheet, the ID of sheet 1 will be 0. There are some instances, like if you create a form and then you create a spreadsheet on top of the form, you will get a sheet 1, but it won't be with an ID of 0. If you go to Google Drive, create a new spreadsheet, that first ID is going to be 0. I'm going to create a new sheet in here just so that you can see. Otherwise, your GID will be over here, and then it's also over here. For whatever reason, Google's spreadsheet URL recently changed, where now you have an edit ? GID and then a hash GID. I don't know why, but the GIDs still remain the same. They are both the same here, you can see. So you just copy whatever comes after GID equals sign. I'm going to pass in 0. I'm going to use a comma, and then you're going to use payloader, which is your function, and then you're going to pass in that payload. You're going to run your cell, cross your fingers, and hope that it works. We get a check mark there, so it looks like it was good. I go into my sheet, go to sheet 1, and check it out. We now have the data that we extracted from Pro Football Reference. This is actually year, even though it's not showing up, so we'll refresh it, and now you can see that we have year in there. So, in summary, we have learned how to write a web scraping application or Python script that allows you to use the Beautiful Soup library to extract the last 5 years of data for any team that appears on profootballreference.com. I hope you found this helpful. I know it's a longer video. Again, just respect to Pro Football Reference, just one of the best websites that are out there. Be responsible when scraping their website and using their data, and making sure that you credit them as much as you can, and donate when you have the opportunity to, because it's a wonderful resource. The purpose of this video is purely academic. But I started my career working with sports data, and hopefully this is an access point for others. So if you want to continue with the tutorial on how to automate the creation of Google Slides decks, please check out the link in the description. I hope you found this helpful, and hopefully you'll check out the next one.